In this lecture, we are going to take our chain rule to a new level and add trig functions to it. So we know the derivatives of our trig functions, and so now we're going to apply them to trig functions, okay? So again, right, in this case with my trig, really my outer function is the cosine function, and I know that my derivative of cosine is negative sine, so I have a negative sine of 4x plus 3. Remember, nothing changes inside. We just do the derivative of the outside. The inside stays the same, and then we multiply by the derivative of the inside. So the derivative of the inside, the 4x plus 3, then is 4. So we could, if we wanted to, we could write it as negative 4 sine of 4x plus 3. Okay, we're starting out kind of simple to start. All right, so again, we have this is my outer function, is the tangent function. This is my inner function. Remember the chain rule we use whenever we have composed functions. And in this case, we have 3x squared inside of tangent. And so the derivative of tangent is secant squared. So we have secant squared of 3x squared, right? Nothing on the inside changes. And then we multiply by the derivative of the inside. And I'm just going to put it out front here because I prefer it here. So this would be 3 times 2, which is 6x. Okay, that's my derivative of 3x squared. Okay, so we'll get a little bit more complicated here. All right, so now this is cosine cubed of 8x squared plus 4. So actually, my outer function is actually the cube. So it might be easier for you to see it. Well, it's usually written like this, as cosine cubed, but what it means is I have the cosine of 8x squared plus 4, then raised to the third power. So I actually have kind of a couple of chains here. I'm going to need the derivative of this, right? I'm going to need the derivative of this, and I'm also going to need the derivative of this, and so we just basically do them one after another. So I'm going to start with, right, it's kind of like a giant x cubed. So the derivative of x cubed would be 3x squared. So we have 3. This is my new x. The whole thing. Nothing changes. And then squared. So we've done the derivative of that part. Now we need to do the derivative of cosine, which is the first function that's inside. The outer function of the inner function, I guess I should say. So the derivative of cosine is negative sine. So I'm going to use parentheses because otherwise it'll look like minus, and then it's not, it's multiplication. So negative sine, and then this still stays inside because now we're just focused on that. That's all we're doing the derivative of. We're just going to ignore everything else, right? And so now we've done the derivative of that. And now the last thing that we haven't done the derivative of is this piece in here. And so then the last thing would be the derivative of 8x squared plus 4, which is 16x. Okay? And you really can leave it like that, although I maybe would like the minus sign pulled out front because otherwise it kind of, even though with the parentheses around it, I think it's easy to mistake it as subtraction, and it's not. So we could technically write it as, well, if I'm going to start simplifying things, I'll multiply the minus, the 16x, and the 3 together, get negative 48x. And then I'll have the cosine of 8x squared plus 4 squared, and then times sine of 8x squared plus 4. You don't need to do that, but it's just a little simplification step. All right, so let's go on to another one. So this time we'll use the product rule. Now here we finally get something that actually is product rule worthy. So we were kind of practicing the product rule before, and we really didn't, there was a lot of times where we could get around using the product rule. And so this time with sine and an algebraic, there's no choice. You can't just combine these in some way with multiplication. Okay, so I'm going to rewrite these as x squared plus 1 to the 1/2 power. And I'm also going to, make sure you catch this little 2 up here. This is the sine of x plus 1, the entire quantity squared. So I'm going to write it like that as my rewrite first. So g prime of x, be careful when you're writing that. When you're doing the rewrite, make sure you just leave it as g. Don't say it's g prime until you start taking the derivative. Okay, so I'm going to do the derivative of this one first just because it's first. So the derivative of 1/2 x squared plus 1, or x squared plus 1 to the 1/2 would be 1/2 x squared plus 1 to the negative 1/2 times the derivative of the inside. This is still a chain, times 2x, and then times the plain thing over here, the sine of x plus 1 quantity squared. So that's the first part. And now the next part, we're just going to have then this times the derivative of that. So then I just have x squared plus 1 to the 1/2. And then my derivative here is a chain too. So I'm kind of running out of space, so I'm going to put multiply, and then I'll put the rest of it down here. So then the derivative of, we're really looking here, right? So the 2 goes first, right? That's my first piece. Here's my sine, that's my next piece, and then in here. Okay, so the first part is 2 sine of x plus 1, and that's to the first power, so I don't need to write that because that's implied there. So I've taken care of this one, right? And then, or I guess up here I'm doing it. So then the derivative of sine would be cosine. The x plus 1 stays inside. And then I multiply by the derivative of the inside. In this case, that's just 1. So you don't really need to write the 1, but I'm just tacking it on for good measure. And there's my product rule. So we might as well go ahead and use the quotient rule then. So I don't really need to rewrite anything in this case. So this 3 means it's on the x squared. Be very careful, right? If it's written up here, or if it's in big parentheses like I used here, right, then it's on the tangent. But in this case, the x is, or the cube is with the x, which is inside. Okay, so my quotient rule is the bottom, which is the tangent of x cubed, times the derivative of the top. So the derivative of the top is negative sine, and then this stays in it. Then times the derivative of the inside. In this time, right, the constant is 0, but the derivative of pi x is pi. Pi is just a number. It's not any different than any other number. It just looks different, right? So that's the bottom times the derivative of the top, and then minus the top times the derivative of the bottom, which the derivative of tangent is secant squared of x cubed, then times 3x squared. Sorry, I'm running out of space. My derivatives are getting too long, right? Okay, and then that is all over then the tangent of x cubed, and then quantity squared. Or I could have written it like this as well, okay? So just using the chain rule as part of my quotient rule. All right, so now this one, this is, I'm kind of pushing the boundaries here. So in this case, I'm going to think of this as cosecant of the square root of x squared plus 1, and then quantity squared. So this time I have, I think, just one more chain. So I'm going to need the derivative of this part, and this part, which is also going to require the chain rule because of the square root. So we actually have like 4 chains in a row. Okay? So we'll start with the outer one, the most outermost one. So that will be 2, and then the inside stays the same, cosecant of the square root of x squared plus 1. And then this will be to the first power, so I don't need to write that. Now the derivative of cosecant is negative cosecant cotangent. So I'm going to put the minus out here because I just don't like putting the minus in the middle. So negative cosecant, and this gets it, cotangent, which is also this with this in it, right? And then, so now I've done that because the derivative of cosecant is negative cosecant cotangent, and this still stayed inside of everything. And now the last thing is I really kind of need to, when I rewrote this, I should have written this as x squared plus 1 to the 1/2, and so now we need to do the derivative of the half part, and so that would be 1/2 x squared plus 1 to the negative 1/2, And now, last but not least, we need the derivative of the inside there, which is then 2x. So we have a chain inside of a chain inside of a chain inside of a chain. Okay, so that's my last example with the trig and the chain rule.